So by now you've defined your proof point in terms of how you would know, and we want to move into how you actually quantify this and pull it all together. So if you look at the slide, in the procedure we talked about associating the proof point with the phase and defining how you would know. Now we're going to talk about reasons for optimism and pessimism and how to go about assessing the numbers. We're going to continue with this HP example, and we've started with the how you would know question over here on the board. So what we're going to do is define the world in two scenarios. One you could think of as success, which I call prove it or pivot. So one scenario, success, is prove it. The other scenario, failure, is pivot. That is, this idea doesn't work out and you're going to have to change directions. So if you're going to do this in a group in particular, but you might also just think about the critical thinking, start in terms of the prove it one, the positive one, and ask yourself, what are the reasons to be optimistic? So here is a definition of how you would know for the HP photo kiosk. And some things, this is basically a brainstorming exercise. So for example, customers love it. That's a reason to be optimistic that they're going to do return purchases. We also know that people love prints. There are billions of prints sold in the year 2000. We also know that people like the kiosk. It's been well designed. So the kiosk is attractive. We also know this meets a real need. People really do want to share information and get it quickly and so on. So you want to take a group in particular and pull it all together and get everybody's ideas about why they could be optimistic. Why they believe it's likely to turn out this way. Then you want to move to the other side and talk about reasons for pessimisms. Why this would pivot. So why might this not work out? Well, perhaps it's a novelty. Perhaps people say they like it, but that's often different than actual use. So use different than reports. Another reason to think that this might not work out is that it's actually a pretty big ask. People don't carry their cameras around. So it requires some planning on the way people work their life. And that's a reason why they might not come back. So it requires planning. It's too heavy a lift for the user, and so on. Get all the reasons. And then you step back and look at the whole thing. See, now you've got a how you would know, and you've got reasons for optimism and reasons for pessimism, and they're all shared. They're not held privately in people's minds where they can cause conflict and unnecessary distraction. It's all right there. When the reasons are up there, you want to call the question. And so what you ask people to do, or do yourself, is independently think of a probability. Now, the probability is narrowly defined. It's, will the plan in this phase as stated deliver evidence that supports this or not? It's not the success of the whole idea, it's the narrow success of the proof point alone. So imagine that you go on vacation, so you're not actually intimately involved in the production, you're sort of a little more distant, and you're going to come back and you're going to say, how'd it go? And your friend's going to hand you a report. You're going to open it up and it's going to say yes or no, we delivered this evidence. So the probability I'm looking for is the probability of the yes narrowly. So to do this, what you do is you want people to think independently and ask them to write down a number, or bring it to mind if you're doing it yourself, that represents their view of how likely this is to happen. Now, we're using probability here as a way of making a judgment about ignorance. There is no right or wrong answer. It's really an expression of your ignorance. So 100% means you're going to come back and deliver the evidence narrowly for sure, and you're willing to be shot if you're wrong. 0 means this is not going to happen for sure, so you're going to be pivoting, and you're willing to be shot if you're wrong. So give people a moment, and you don't want too much talk because you want people to think independently. Then ask what the numbers might be. And so just write them down. So maybe the first person says 30%, and the next person says 40%, and somebody says 25%, and somebody else says 30%, something like that. So if you look at this, this set of data here, I'd say that these are actually very close together. This is a very low precision kind of number. It's got less than one significant figure. So I would just pick something in the middle here, like 30%, and use that as my probability of success. Now you might find that there's an outlier. What you might find is somebody says 70%. Now the 70% person is saying the opposite of what the other people are saying. So I'm not worried about small differences, I'm worried about big differences. And so what you can do with that is inquire. So go to the 70% person and say, well, why are you so optimistic? And what you're looking for are new reasons, and you want to share information that wasn't there before. You might also want to go to the pessimistic person and ask them and see if they come up with new reasons. If there's a lot of new evidence, you might want to redo the poll. So sometimes people change their minds because it's really about sharing the content. So that's the basic procedure. So if I come back to the summary here on the chart, you see the overall procedure is to associate the proof point with the phase, define how you would know, and in this case, get reasons for optimism and pessimism, get sort of just a brainstorm list, don't argue too much, assess the numbers independently, compare them, select one, and if necessary, inquire into the really big differences. Don't worry about the small stuff and see if that changes anybody's mind. But at the end of the day, you need to select some number you're going to use to represent the probability of this proof point and of this phase.